see you all in Bangkok. Today, Sudesh will be talking about tunables in glibc. Sudesh works at Linaro and is also a glibc maintainer.
Thank you, Maxim.
If you have any questions, sorry for interruption, please raise your hand and I'll come by with the mic so that, first of all, everyone can hear you and we can get your question on the record.
Do you want questions during or after or compare?
No preference, just raise your hand and I'll try to answer to the best of my capabilities. All right, thank you everyone for coming. Tunables. So the subtitle is a little misleading. It says the future of platform optimization selection in glibc. The grand plan is to have it select as many things as it can, basically customize glibc in whichever way a user or a distribution maintainer would want to. So this is what we're going to do. I have a quick, probably 20-25 minute presentation about what I've done so far, the plans that I have in future, and then I'd like to have questions, and as many, the better. So to begin with, I'm going to start with the problem statement, the problem that we are trying to solve. And based on that, I'll describe the project goal, basically how we're going to solve those problems. And finally, I'm going to talk about the roadmap, which is the future of the project, which is the future of optimization selection. So the problem is a little, it started probably somewhere around 2013, where we had a customer issue at the place I was working back then in Red Hat. And we realized that to implement a customization for the customer would mean a lot of code change, and we would have to maintain that change forever. And at that time, we visualized this ideal framework where we would add these customizations, and we could just turn them on for Red Hat Enterprise Linux, and it would be off for everything else. And after that, about half a dozen problems that we came up with within Red Hat and outside the greater upstream community, the answer for that seemed to be the same framework, wherein we abstract all of the constants inside glibc and kind of provide this uniform framework where we are changing these values. So there were two major problems that we identified during all of that time. The first is constants inside glibc. So there are a fair number of them, like the number of thread caches inside, the stack caches inside glibc, or the initial size of the allocation selection, whether you select, whether you allocate on the heap or you allocate on using mmap, a lot of these things. And the constants that were selected maybe 20 years ago based on the state of the art back then. Some of them were heuristics, where it was just thought that it would be a good idea to, say, for example, set the buffer for streams to page size. It seemed like a good idea back then, but then a lot of people countered that by saying that the read ahead for the kernel is big enough, so you don't actually need a buffer at all. So you have all of these cases where we thought those constants back then were sensible, but that they don't apply anymore. That was one part of the problem. The other part of the problem was customizations that we already had in place, parameter tweaking that we already had in place. We had environment variables that we could export, but then the names for those environment variables were ad hoc, and they were basically introduced at that time. Malloc mmap threshold with a trailing underscore, which everyone seemed to miss all the time, and a lot of other similar variables. And finally, we wanted to be able to provide a framework to distributions so that they can expose their own tunables, basically have their own little tweaks to the library. And when they're doing that, they should not have to make gratuitous modifications to the source code, but be able to kind of provide this one set of changes, very well-defined changes, and based on that, the user also comes to know that these are specific customizations and they won't apply across distributions. So based on these problems, we came up with specific goals for the project. These could be seen as features that we want implemented in this feature set. So the first one is already, well, it's not implemented, it's there on a branch, and it's in discussion, but there's real code for it, which is per process tunable values. The idea is, and this also includes a kind of a framework for tunables in general. And the idea here is that a user can tweak runtime values, tweak constants inside glibc for that process using an environment variable. The other features for users are still in progress. I'll probably talk about them in detail later. One is the ability to tune these values per user. So it's not just a specific process, but it's all processes of a specific user, or even system-wide, where the entire system has a set of values that it inherits, or all applications in the system has a set of values that it inherits and uses through the lifetime of the system. And finally, the holy grail, which is to tweak tunables at runtime. For distribution maintainers, we wanted them to be able to add distribution-specific tunables, and finally also be able to set distribution defaults. And the defaults basically just loop back to the system-wide tunable values. But they have very different use cases. So this slide essentially is all that is implemented so far. Of course, there's a lot of scaffolding that goes under it, but this is the feature set. You have every tunable inside the library would have a namespace like this, where you have a top namespace which describes the applicability of the tunable, as in whether it is all of glibc, which means any glibc port, would it be, whether it's for Ubuntu or Red Hat or Fedora, would have this tunable. And then you have the module, in this case malloc, and then you have tunables within that module, which is check or arena max or mmap threshold, trim threshold, and so on and so forth. So there's this uniformity in namespace that we've aimed to maintain, and that's evident there. So the entire name consists of the top namespace. Yeah.
So looking at the names of the tunables, these do not look very user-friendly. So is this tunables meant to be used by end users who do not know glibc internals, or whether they are intended to be used primarily by people who know internals of glibc?
So these are actually for users, and for these specific values like malloc check and arena max, if you're talking about them, they're features that are already implemented in the library, and they're documented in the libc manual. So if you're looking to tweak the memory allocator right now, you could read the manual and you'd find not exactly these tunables, but you'll find, for example, for malloc check, you'll find this arcane environment variable called malloc underscore check underscore, which is set to a certain value to, well, not change the behavior of the allocator, but enhance the behavior of the allocator so that it performs additional checking, and then whether it dumps core or not, whether it dumps a full trace on screen or not, and so on and so forth. So it is definitely advanced. So it's not something that John Doe with a laptop would do in the beginning, but I can imagine a systems administrator or an integrator picking this up, because they would already have the knowledge of these kind of tunables existing inside glibc, but in a different form. Right, so you have these tunables with their names and values, and they're separated by a colon, and that becomes your tunable string, which essentially describes all of the things that you want to tune in that process. You export that string to the environment variable libc_tunables, and the process should pick that up. Except, of course, it's a setuid process, in which case you don't want it to pick up these values. Of course, as is the case with all user interfaces, there's always another viewpoint where someone might think an alternate interface is better. And in fact, this was the interface that I had originally implemented last year, and then I moved on to the previous one, where every tunable gets its own environment variable, with namespaces now separated with underscores instead of the dots. So there's not a lot to add to that in addition to what we saw previously. So the future of tunables for users I've got in the roadmap, so I'll talk about it later. Tunables for distributions. This one is a little more, it has deeper significance because there have been a lot of companies or a lot of distributions have expressed desire to customize their glibc in many ways without actually having to touch the code a lot, right? For example, you have Intel and IBM, they have localization enabled in their processors. They want to be able to enable localization. Now, localization is a generic glibc thing, right? So they can have localization as a glibc namespace tunable. But then if it was something that only Intel was doing, then it would have to be an Intel namespace and nothing else. So that's the main thing, a main criterion for a distribution-specific tunable, in that it should be specific to the distribution only and not useful to anyone else. The moment it becomes useful to anyone else and becomes fit for mainline, that's a top level namespace, a glibc namespace tunable. So we know that these tunables, as users, we would know that these tunables are not available in all distributions. So if you're a user and you've been asked, say, by IBM or Intel, saying that here's a tunable or here's a set of tunables that you can use on our processors to get maximum performance out of your system, then you would know immediately that these tunables are specific, or a subset of these tunables are specific to this processor only, or this distribution only, right? And you would not attempt to try those tunables elsewhere. Or if you want to build a portable program, as you would if you're deploying them to a cloud where you're not sure what the target platform is, you would want to avoid these tunables and only focus on tunables that are available in the top level namespace. All right, finally the roadmap. And obviously I'm going to do a lot of hand waving in this one, if I wasn't doing a lot already. System-wide and per-user configuration files. The main contention for this, all right, so the feature over here is to be able to provide users with or system administrators, more importantly, to provide them with the ability to set defaults for the entire system. And the defaults for, say, for the entire system would also act as limits beyond which you cannot, similar to the U limits that you have on Linux, where you can only tweak your tunable to the extent of that default set by the system administrator. The main concern with that is performance, because, or the main concern that's been talked about is performance, because it involves opening and reading an additional file, which is an overhead at the start of the process. I would argue it's not much of an overhead, because it would happen once in the lifetime of a process. And the second point being that it's going to be a file that's going to be open for every process in the system, so it's always going to be in the read ahead. But then we need to do a comprehensive study to actually understand what kind of performance implications would come out from this. But finally, assuming that it does work out, we would have this one file where system administrators can set limits, and then based on that, you would probably even have a per user file where you can set limits for tunables for all of the process owned by the user. The system level file will also help with distribution defaults. And the different aspect that I talked about with distribution defaults is that distribution maintainers then can have custom-made files for each of their images. Like, for example, for cloud images that have less than 1 gig of RAM, you would disable per thread arenas, because per thread arenas tend to blow up memory consumption at the cost of performance. So these are the kind of customizations that distribution maintainers can do on the fly for each of their class of images. And finally, like I said, the holy grail, which is tweaking tunables at runtime. I've mentioned the example as being in the proc file system because that is like a pipe dream for me, but that's probably not going to happen. But then that kind of shows the idea that I have in mind, which is the ability to, at runtime, give a process ID or a thread ID of a task and modify a certain aspect of that running image. Like in this case, let's say, for example, if you have a web server that's been running for 6 months and you're experiencing high load, but then you know for a fact that, or high memory consumption, and you know for a fact that reducing the stack size would, say, reduce your memory consumption by, say, 20% or something like that, then you could go ahead and do that. And to do that, you should not have to restart your process. You could just fire away this command, echo whatever value to that tunable name, and it should modify the future thread stack sizes.
Have you discussed this with kernel maintainers, the possible API for tunables? Or
No. The reason why I haven't done
is
that...
it possible to do without kernel side?
Yes.
To modify at runtime without kernel support?
So if you want to plug into the proc file system like this, you need kernel support. But then the alternate, actually the original idea was to have a global shared memory where basically have a global shared memory space within every process which someone can write into. But that's a little bit tricky because then you have very little control over what can be written into that process. So that's still something that's an evolving idea. Like I said, it's a pipe dream, right? But then the major issue over here is security, because we want to be sure that we are exposing very specific tunables only and not everything in the address space. And also make sure that the values that you can set in those tunables are also sanitized. All right, so this is all I had. I'm willing to take questions, please.
Yeah, I'll get some. Actually, I'll grab next.
So have you been challenged on the performance implication of replacing constants with dynamic selection at runtime?
Nope. That's
Really?
Yes, it's surprising.
So
No.
yeah, it's like every constant is no longer a direct branch necessarily. You're going through a resolver, right, to get to
Right.
those constants?
Right. I think, so I guess the main driver for this has been customizability, because the idea that you can only have, let's say, a thread cache size of, the thread stack cache size of, say, 32 megs or 64 megs, whatever is the default. It may have been valid in the 90s, but then if you're looking at 2016 with, say, a massive server rack, and you have a web server that does 128 threads, you want to have a larger thread stack cache. So those are the kind of requirements that are driving this.
Right, right. So you said the title is a bit of a misnomer. How would you use this for platform optimization selection for a microarchitecture, for instance? What would that interface look like?
I intentionally left that out. And I was hoping you'd ask me that question.
Okay, good.
So, in fact, the most important way that you could do platform optimization selection is by, I won't say replacing ifunc, but by augmenting ifunc. So for the benefit of everyone, ifunc is a mechanism by which glibc deploys optimal routines for a specific processor, and not a class of processor, but a specific processor, like a specific microarchitecture. We can't do that precisely yet with ARM, but in the Intel world, you'd have something that uses AVX, like for Core i7s, Core i5s. You could have specific routines that are optimized for that core, right? So maybe someday we'll have something like that for ARM as well. What you could do with tunables is that if, despite what the underlying architecture is, if you know for a fact that your workload performs best not with the optimally selected string routine, but with some other string routine, you could select that routine via tunables. So that's one way in which to do it.
Overriding the default then?
Overriding defaults, default behavior.
Okay. Any other questions?
Sorry. What about the API stability? For instance, on the version X, you provide that tunables. Do you intend to provide the same tunables in the future releases, or there is no?
As of now, no. As of now, none.
Okay.
There is no guarantee right now. I can't promise yet, but then, right. So Carlos's stand on this is no, never, right? Because we don't want to make any promises that we regret, say 5 years down the line. But I'd like to think that there'd be this one core set of tunables that we provide guaranteed stability for a long term. But as of now, no, there are no API stability guarantees. There's a question there.
Yeah, how would you validate the quality of tuned library? I mean, supposedly you should test a library which different tunable options to make sure you have a certain confidence on the quality. But if there's too many parameters can be tuned, then make it impossible to test anything. How would you solve that problem?
So typically you would choose to tune parameters inside the library only when you have a problem, right? And you're trying to solve a specific problem, like scaling a server, scaling a web server, for example, where you want to adjust the stack sizes, you want to be able to adjust the stack cache size, and so on and so forth. So based on your problem, you'd already come up with a list of tunables that you want to try out, right? And once you have come up with those, that list of tunables, then it's just a matter of tweaking those based on your, based on experimentation or whatever input you have from your workload, and coming up with the optimal set. So it shouldn't have to be, so your approach would never be, I have this list of tunables, now let me pick them off. It always should be look at the problem and then isolate tunables based on that problem.
So my question is more from the validation purpose of this library. So if you pick a stack size as 1 mega, you probably test you test with 1 mega of stack size before release it. But someone may choose to set like 10 mega, then it was not tested before, so it may run into problem. So how would you test that? Would you test it with 100 mega to get some confidence? Because that might be the maximum number before you release them. So that's
So you're talking about performance validation or correctness validation?
correctness validation.
Correctness validation. Okay, so correctness validation usually should not be affected by tunable value fluctuation, but then technically, yes. Sorry? I don't think so. Yeah, in theory it shouldn't. Or rather, in theory it should, but in practical application it should not, because you should always have a limit, right? On the number, on the basically the threshold that you would have, the minimum and maximum, that should always limit the number of tests that you're going to run for each tunable. So that should be attainable, is what I'm saying.
But you should run, right? You should run these tests. At least you should run the tests for these tunables.
You should run the test,
Oh, yes.
absolutely. So every distribution has to do that. You cannot do that at the upstream level.
Is it okay for tunables to be connected so that a value of tunable 1 can be only A and B if value of tunable 2 is C? So, or are they supposed to be fully disconnected and not influence each other?
That's a good question. Right now, I don't think any of the tunables that we have identified are connected in any way.
But is there a design decision?
Right, okay, so right now we don't need any of that. We don't need an infrastructure to actually make that kind of a decision, but if we do at some point, we should probably add that.
So currently, Linux distributions, when they build the glibc, they determine what it can and can't be used for. Do you envision, in the case that Joey mentioned, a distro being able to lock down a specific tunable and say, you know what, you can't set a stack size over a certain amount? Do you envision that being able to happen?
So a distribution doing that at compile time, as
Yeah.
opposed to doing
at
it
compile time.
using system-wide
At
tunables.
compile time.
At compile time, that would probably require an additional patch. I don't think, I don't think any distribution has expressed interest in doing something like this at compile time. And it usually is not desirable for them, because the farther away they get from rebuilding core libraries and hence rebuilding entire distributions, the better it is for them.
I could just imagine a support nightmare.
Right, right. If there's an error there, or if there's an issue that they need to change, that at any point in time, they'd have to rebuild everything, or at least the library, and release it again.
So have you took a look at how other operating systems do this? For example, in Android, we use something similar. We use some build props that we later read at runtime, and we use them in a shared memory space, as you said at the beginning. So why not do it like this? It seems counterintuitive to me to ask from the kernel to implement something that the user space.
Oh, so right, the proc example is, it doesn't exist. It's just a fantasy. It's basically an example of how I would like it to look. It's not something that's already implemented, and I definitely don't intend to implement it as proc.
Yep.
A shared memory is probably how we're going to be, how we're going to eventually implement it. It'll probably look prettier than, SHM get, whatever.
I thought that you already had in mind some
No.
drawbacks of
That's
using a shared
that's
memory.
also an additional context switch and so on. We don't want to do that, no. I agree, yeah. Right. So I guess whatever scaffolding we have, it'll have to be on the library side. Whatever validations we do, they'll have to be on the library side and not at the tool side. because of obvious reasons, because of security, blah, 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 right? So on the tool side, it'll probably be multiple interfaces. It could be an API, which glibc exposes, or the Tunables subsystem exposes, that any number of administrative tools can use to make changes to the tunables, right? Or it could be shared memory, it could be anything. We've not really thought about what it's going to be because it's probably a couple of years down the line.
Yeah, just quickly. So what's the reception by the other maintainers and gatekeepers, particularly the godfather of the project?
For tunables as a feature, there's no argument. There's no discussion about it. Everyone needs it. Everyone wants it. How it should look is a completely different question. So right now, the patches that I have in play are, one, to kind of add this framework, to add some existing environment variables into the tunable framework, and the other one is to implement the actual API so that for the way it would look to the users. And well, I would have liked to say that the first patch is without contention, but the first patch also has some contention now, where I need to look at how I represent tunables internally. The second patch definitely has a lot of contention, where already there are two camps, where there's one set of maintainers who want a single environment variable with the tunable string, and then there's another where you have an environment variable for each tunable. And as far as I can tell, Roland is in neither camps. So he has an abstract third idea which none of us have understood yet.
What's the implementation status? What's working, what's not?
So the first bit is working, which is per process tunables. The patches are on Siddesh/tunables branch on the upstream FSF tree. And you should be able to use the malloc tunables, that is whatever malloc environment variables that you were using, malloc arena max, malloc mmap threshold, trim threshold, check, and so on and so forth. And there are tunable equivalents for all of those now. Any other questions? Going once? Twice?
I have one more.
Could always count on you.
Yep. Who else is working on this with you? Are you looking for help?
In terms of management effort or programming effort? Programming, no one, but there are quite a few people who want it done. And so I think the understanding was that I want to do all of the work, which is absolutely not true, especially since I don't have the time to constantly give to this project. So any help that I can get, I'll be more than willing to accept that. All right, once again, going once, twice, and gone. Thank you.